Hey, this is a demo of CTX, my submission for the Lingo.dev hackathon. CTX is a CLI tool that makes Lingo.dev translations consistent, natural, and on-brand. Let me show you why it needs to exist and how it works. Lingo.dev is an AI translation tool that plugs into your codebase. You point at your source code files and it translates them into every targeted language. Fast, cheap, works great, but it translates each file independently. Separate prompt, separate context window, no shared memory. The model translating your navbar has no idea what the model translating your settings page decided. Both have no idea what the other one is doing. That's the root problem. And it's not a model quality problem. You can throw the best LLM on the planet at this, but it would still get this wrong because these aren't language mistakes, they are context mistakes. Here's an example. The string says season to taste. In a cooking app, that means add salt or add pepper. Without that context, the model translates it as add spices. In Gujarati, mishi's masalo nako instead of the intended meaning. A cook following the instruction might add cumin or chili powder instead of a pinch of salt. The model knows the word season. It picks the wrong meaning because no one told it this was a recipe or what this one part meant in context. Here's another example. A news glossary term, quantitative easing, being translated for Hindi readers. Without context, the model's definition ended with accuracy lost in translation. It gave up. With added context, the model explained it clearly, using the Reserve Bank of India as an example, something every Hindi reader understands instantly. Same model, same term. It did the same thing with breaking news. It transliterated it into Devanagari script. But every Hindi news channel uses Taza Khabar. Every product has a term like this. The model's ability isn't the bottleneck. The missing context is. We tested this on 4 projects, a news platform, a cooking app, and 2 crypto apps, and the pattern was everywhere. Hindi UI labels were English words in Devanagari script instead of actual Hindi. Gujarati cooking instructions were under-translated or needed a cultural bridge which wasn't there. Crypto terminology was inconsistent across files, grammatically correct but not consistent, not natural, not on-brand. That's the gap. Lingo.dev translates file by file in isolation. No shared memory and no shared voice. How CTX fixes this? CTX solves this by generating one file, lingo-context.md, a structured translation brief that gets injected into every single translation prompt Lingo.dev makes. So now, even though Lingo.dev still translates file by file, every file sees the same context, same rules, same vocabulary, same voice. Here's what that file contains. First, app, what the product does. Factual, no marketing fluff, just enough for the translator to understand what it's translating. Second, tone and voice, not be professional. That's useless. Specific rules. Use informal tú in Spanish. Keep CTAs under 4 words. Address the reader as ser or anon. Never use exclamation marks. Third, audience. Who reads these strings? A crypto degen? A Hindi-speaking home cook? An Indian journalist? This changes everything about how you translate. Fourth, per language rules. Hindi needs more explanation built into translations. Gujarati readers need cultural bridge building. Spanish has established alternatives for English journalism terms. Use them. German compound nouns. Japanese politeness levels. Each language gets its own strategy. Fifth, tricky terms. Every ambiguous, idiomatic, or domain-specific term with exact guidance per locale. Ape in, keep it. Transliterate it as apeando in Spanish, epping in Hindi. Ship it means launch, not mail. Sixth, files. Per file rules for files that need special handling. Once generated, CTX injects this entire brief into the provider.prompt field of your i18n.json. Lingo.dev picks it up automatically. No manual step needed. Part 4. Fresh mode. The full pipeline. Let me walk you through how the whole thing works. I've got this flowchart that shows the full pipeline. So it all starts with lingo-ctx run. First thing it does is read your i18n.json. That's where it picks up your source locale, your targets, your file paths. Basically, the map of your project. Now here's where it gets interesting. There's a fork. Does lingo-context.md already exist? If yes, we jump to the right, load it up and keep going. If no, this is our first run. We go left into fresh mode. So in fresh mode, CTX starts by scanning your actual project files, your package.json, your readme, your existing strings. It's trying to understand what you've built, and then, optionally, the research agent kicks in. And remember, it goes to the internet only after it's already read your project. So it's not blindly searching localization best practices. It already knows your domain, your terms, your tone. It searches with that knowledge. And from all of that, Claude generates lingo-context.md from scratch. Your app description, tone rules, audience, per-language strategies, tricky terms, the whole brief. Now both paths come together here. Whether the context was freshly generated or it already existed from a previous run, it's loaded. App description, tone, user base, language-specific rules, all in memory, ready to go. Next, it scans all your source files from the bucket paths in i18n.json. And for each file, it asks a smart question. Does this file need its own context, or is the global context enough? So if your main UI strings follow the global tone, cool, skip it. But if you've got an errors.json that needs a calmer voice, or a legal page that needs formal register, CTX catches that and appends a file-specific context block to lingo-context.md. So the translator gets both global rules plus per file overrides where they matter. Then comes the JSON translator notes. For each string, CTX generates an inline comment using the global context, the file context, the key name, and the actual value. These are per string instructions sitting right next to the string in your source file. Tone tags, length limits, don't translate this term, that kind of thing. And the final step, Lingo.dev run. Lingo.dev runs the actual translation, but now it's got everything. The provider prompt from lingo-context.md, the per file overrides, the per string notes. Every file, every locale, same shared context. And here's what that actually looks like in the terminal. You can see the tool calls, list_files, read_file, web_search. The research agent doing its thing, the context being generated, the review step where you approve it, the JSON injection, and then Lingo running with full context. Part 5. Running Lingo.dev. Without context versus with context. Alright, so now let me show you the actual translation runs. This is Lingo.dev running on all 4 projects: Dispatch, Tastebud, Nexus, and Vaultly, without any context. No lingo-context.md, no provider prompt, nothing. Just raw source files going in. You'll notice I've added commit timestamps on the video, so you can cross-reference every output with the actual Git history. Everything is verifiable. I'm not cherry-picking results. Quick heads up, the bottom of the terminal got cut off in a couple of these recordings. OBS cropping issue, fixed it too late. But you can still see the main outputs and the translation results coming through. So that's attempt 1. Lingo.dev did its job. Translations came out, grammatically correct, no errors. But each file was translated in its own bubble, no shared context. Now the same 4 projects, but this time CTX has already run. Lingo-context.md exists. The provider prompt is loaded. The JSON-C files have per string translator notes. Again, commit timestamps are on screen. You can fact check every single output against Git. Same projects, same model, same Lingo.dev pipeline. The only difference is the context. Now before attempt 2, we delete the previous translated files and the context file. Clean slate. That way, the comparison is fair. Here's all 4 projects running at once. All fresh mode. No lingo-context.md exists on any of them. You can see each one going through the same pipeline. First, it asks if you want to add specific instructions. Default is blank. Just hit enter. Then the research agent, scanning project files first, then the web. Then it generates lingo-context.md. Review step. Accept. JSON injection. Per-string notes above each key. Accept. And finally, npx lingo.dev at latest run. Lingo translates with the full context loaded. All 4 projects, same flow, same model, same lingo.dev pipeline. The only difference from attempt 1 is the context. One thing you'll notice, in the news app and recipe app, there's some English text still sitting in the translations. That's a bug, but I kept it there on purpose. We're going to use that later to test our change detection. Fix those strings, run CTX again, and see if it picks up only what changed. Part 6. Before and after the results. Now here's the thing, we've got 4 projects, multiple languages each, hundreds of translated strings. It's impossible to manually review all of that. So I used an AI reviewer, gave it the git diffs from both attempts and had it compare every single string line by line. Let me walk you through what it found. Same model, Claude Haiku, same Lingo.dev pipeline. The only variable is the context brief. Here's the actual diff. You can see it right here. Action.subscribe changed from subscribe kare to sadasyata le. Action.share from share kare to saja kare. Action.save from save kare to saheje. English words in Devanagari replaced with actual Hindi. Same diff. You can verify it yourself. Commit hashes are right there. And look at the term definitions. Term.regulatory_capture. In attempt 1, it ends with अधिकांश अनुवादों में सटीकता खो जाती है. Accuracy is lost in most translations. The model gave up. In attempt 2, same key. It's got an RBI example. Explains the concept using something every Hindi reader already knows. That's the context file doing its job. Now the recipe app. Look at this diff. Action.blanch went from blanch karo, just a transliteration, to ukalta pani ma mukia baad tarat baraf jarma dubao, the full blanching technique with the ice bath step. Action gently mixed together, actual Gujarati cooking instructions. And here, sub.ghee. Attempt 1 said, Vadu makfadi jevo swad, peanut-like flavor. Wrong. Ghee has an almond-like nutty flavor. Attempt 2, badami swad, almond-like. The tricky terms table in the context file had the exact flavor profile. And recipe names. Shakshuka was translated to shakshuka in attempt 1. A Gujarati cook searching for that recipe online will never find it under that name. Attempt 2 keeps it as shakshuka because the context file said don't translate iconic recipe names. So to sum up the news and recipe apps, with context, you get actual native language words instead of English in Devanagari. You get cooking instructions that explain the full technique, not just a transliteration. You get correct flavor profiles because the tricky terms table caught it. You get iconic dish names preserved so they are searchable. And you get glossary terms that actually teach the reader instead of giving up. All from one context file. Now the crypto apps are interesting because the better translation sometimes has more English in it. The context file told the model, keep crypto slang in English. Alpha, whale, degen, rect. These are identity markers. Look at order.slippage.warning in the diff. Attempt 1 reads like a bank notice. इस trade में आपका बड़ा नुकसान हो सकता है. Attempt 2, आप इस trade में wrecked हो सकते हैं. You could get wrecked. That's how crypto people actually talk. Portfolio.diamond. Attempt 1 describes the concept, मजबूती से पकड़े रहने का फ़ायदा. Attempt 2 uses the actual slang, diamond hands काम आ गए. Diamond hands, the identity marker. In Spanish, look at the hero subheading. Attempt 1, intercambia, gana y conecta entre 12 cadenas. Textbook Spanish. Attempt 2, swapea, gana y brichea a través de 12 chains. That's how Spanish DeFi users actually talk. The context file knew that. And emojis. The context said carry tone, don't strip them. You can see in the market JSON-C diff, attempt 1, 0 emojis. Attempt 2, they're there. Every single improvement the reviewer found traces back to a specific line in Lingo.context.md. The model didn't change. The brief changed. That's the thesis. The quality ceiling is set by the context you give the model, not by which model you use. Localization isn't a one-time thing. You're always shipping new strings, changing copy, adding features. CTX handles all of that. So first, I just run CTX on a project where nothing has changed. And watch. It says, no new changes detected. The hashes match. Nothing to do. Done. Now I'm going to delete a section from lingo-context.md, remove some content, run CTX again. Now it detects the change. The file hash is different from what it had stored. It enters update mode, processes only the affected file, and regenerates the missing section. Now I restore the file back to how it was. Run CTX one more time, and no new changes detected. The hash matches again. CTX knows this file is back to its previous state and doesn't waste time reprocessing it. That's the hash system. It tracks content, not timestamps. If the content hasn't actually changed, it doesn't run. If you cancel mid-run, hashes aren't saved, so next time it picks up where it left off. No partial state, no corruption. If you've been shipping without CTX and want to catch up, CTX commits 5. Same pipeline, but diffs against the last 5 git commits instead of uncommitted changes. Adopt CTX on any existing project. Retroactively build context from recent work. Last feature, CTX voices generates a prose brand voice per target locale derived from your Lingo.context.md. Same review loop. Accept, skip, or give feedback. Voices go into i18n.json under provider.voices, picked up by Lingo.dev automatically. So that's CTX. Lingo.dev is a great tool, but it translates every file in its own bubble. No shared memory, no shared voice. And you saw what that produces. English words in Devanagari, inconsistent terminology, cooking instructions that miss the whole point. CTX gives every file the same brain. One context brief generated from your actual project injected into every translation prompt. Your vocabulary, your tone, your rules across every file and every locale. It bootstraps itself, reads your project, searches the web, builds the brief. It stays current, only processes what actually changed. And if you're adopting it on an existing project, commit mode catches you up from Git history. The model was the same both times. The translations were correct both times. The difference was context. And that's all CTX is. The right context in the right place every time. Thanks for watching. If you want to try it, links in the description.